Yeah, so I'm going to tell you how I finished this problem off. Okay, so basically a lot of the problem was we figured out how to get this expression close to 49, right? And we got it less than like 50 or 49 and a half, but we couldn't get it to be less than 49. Does that make sense? Okay. Um, and to get it to sort of close to 49 is actually not hard. You just need to basically make like every second number go to 0, basically. Yeah. Okay, so now I just want to show you how to get it less than 49. Yeah. Okay, so actually doing it for 99 is not actually that different from doing for 5 terms. Okay, so you can actually show this idea pretty well for 5 terms. So when I solved it, I went to 5 terms. Okay. So if it was 5, it looks like this. So it's a2 over a1 plus a2 plus a3. Showing you a3 on a2 plus a3 plus a4 plus a4 on. So it's basically always like the 2 next to it, yeah? So it's 3 plus 4 plus 5, yeah? And then when it gets to 5, it starts wrapping back around, so it's a4, a5 plus a1 again, yeah? And then at the very end, it's a1 on a5 plus a1 plus a2, yeah? And so, like, what's the number we're trying to show for the 5 case? You understand? You know what the number is? Does anyone know? 2, yeah? So we're trying to show this is less than 2. Does that make sense? Okay, so here's an interesting idea. These kind of things, you kind of see them, but you don't know if they're going to work because sometimes it looks a bit complicated. So what happens if, for example, you have 1, 2, 3 here, right? You have 2, 3, 4 here and 3, 4, 5 here, yeah? What if you can get these to all be 1, 2, 3? So if you can get, what if you can get this to be 1, 2, 3, right? Because remember in the 3 by 3 case, they all got the same denominator, right? What if you can get this denominator to be the same as that? And this denominator to be the same as that, 1, 2, 3 as well, yeah? You see how you can do that? Okay, so this is where like you have to assume some, you might lose some generality. So if you assume, so you know, like the bigger the denominator, you know what denominator means, right? The bigger the thing on the bottom, the smaller the fraction, right? Okay, so if this thing is if a1 is bigger than a4, yeah, then this fraction is smaller than or equal to a3 on a2 plus a3 plus a1. Does that make sense? Does that make sense? So if this a4 is smaller than a1, then you can basically replace this by the denominator you want. Does that make sense? Okay. The same thing applies here, okay? The same thing applies here. So you want to replace a5 by a3, right? If a5 is smaller than or equal to a3, yeah, then this thing is less than a3 plus a2 plus a1, right? Okay, I wrote that backwards there. a1 plus a2, yeah? Does that make sense? So if these two things are true, right? Yeah? Then we have these 3 things added together. What do you get? You get a1, you get the same denominator, it's less than something with the same denominator, right? And then on the numerator, it's a1 plus a2 plus a3, right? Does that make sense? So focus, okay. So if that's the case, then all three of these is less than 1, right? That makes sense? And we know these two together is less than 1 as well, right? That makes sense? Because this is, you remember why these were less than 1 together? Yeah, because they're less than just a4 plus a5 in the denominator, right? And that's 1, yeah? So if we got those three less than 1, then we got the whole thing less than 2. That makes sense? Okay. So we can prove it if we make these two assumptions, yeah? Okay? But we're not just allowed to make assumptions, right? Okay? But well, let's see how to make these assumptions work, yeah? So the first step I want to do, you can pick one of those inequalities. It could be either one, but I'll take 3 and 5, yeah? Okay? Can you see that I can, so I'm gonna say this and you can ask me what it means. So can you see I can actually log that A3 is greater than A5.
I think I've heard the word log.
It's not a word, it's like an abbreviation. Okay. Have you guys heard of log? So it's without loss of generality, okay? So, because the whole point is you can't just assume stuff, right? Because like you're not proving it for everything now, right? But when you say log, you're like, I'm actually assuming this. It looks like I've lost generality because I'm specializing with my assumption, but I haven't actually lost any generality, okay? So the question is, do you know how we can assume A3 is greater than A5 for free? How?
There's only an A2 and A5 in the actual question.
So remember, these things are like cycling in a circle, yeah? Does that make sense? So there's a few ways to, do you guys know? Do you guys know? Do you know how to log in this case? So we have 5 numbers in a circle, right? So suppose like, see if A3 is smaller than A5, right? Yeah? We can kind of reorder the things and renumber them so that, you know what I'm saying? You can kind of, so this is going clockwise now, right? I can make it go anti-clockwise, and then A3 is the A5, and A5 is the A3, and then it'll be bigger. Does that make sense? Because I don't know what the numbers are anyway, right? So I can just jumble them around and preserve the symmetry, the cyclic symmetry, right? Does that make sense? Does this make sense to anyone? Does it? It doesn't. Okay, so let's just say A3 is smaller than A5, yeah? Okay. So what can I do? Well, I can relabel this number B5, okay? And then I'll label this number B4. Actually, I should go around. I'll label this number B4 and label this number B3. Oh, oops, that doesn't work on them. So I'll label this number B5. I'll label this number B4. I'll label this number B3, this number B2, and this number B1. You see? That makes sense? So I have a new labeling of the numbers, and they still go around in a circle, so I get the same sum, right? But now the B5 is smaller than the B3. Does that make sense? Yeah? Yes? You have a question? Alright. Alright. Lucas, does that make sense? Lucas?
Yeah.
Does that make sense?
Yeah.
Okay, good. Okay, so basically I get one assumption for free, right? But because I've already used it on that, I can't get the other assumption for free. Does that make sense? Because now I've basically fixed the positions of the numbers. I can't cycle them anymore. Yeah. So I get this one for free, and this one may or may not be true, right? And of course it can't be true. We know that 3 of them isn't always less than 1, right? That makes sense? So there has to be an assumption to make it less than 1. Yeah? Okay. So here's what's interesting, okay? So this is called a chase, okay? Because now we know one of them's true, right? The only thing for this to fail is the other one not being true. Yeah? And when there's only one thing to look at every step, it's called a chase. Okay? And if you can chase it to the end, something interesting might or might not happen. Okay, so here we have A1 is greater than A4, yeah? So I'm gonna assume A1 is actually less than A4. Does that make sense? Because if it's greater than A4, we're done, right? So I want to show what happens if it's less than A4. Okay? Okay. So we're all understanding so far, right? Okay, so now if A1 is less than A4, I'm gonna look for a chance to replace A1 by A4. Does that make sense? So before I was replacing A4 by A1, yeah? Now I want to replace A1 by A4. Does that make sense? Because now it's smaller. If I replace A1 by A4, the fraction will be smaller. Yeah? You understand? Because A4, if I replace A1 and it's in the bottom, it's in the denominator, by something bigger, then the whole fraction is getting smaller, right? So this is one of the A1s I want to replace, yeah? And what I'm trying to get is I'm trying to get the A2, A3, A4, yeah? So this one has already A2, A3, A4, yeah? That makes sense? And so if we can somehow get the A2, A3, A4, so this is the only other one that has 3 and like 2 of the 3, right? Does that make sense? Yeah? Okay, so to get the A2, A3, A4, what do we need to do? Well, we need to change that A5 to an A2, right? That makes sense? Okay, so to change the A5 to A2, what do we need to do, Michael? Oh, Michelle? No, don't say stuff. Just try not to talk, okay? You gotta think before you talk. So, what about you? Anyone? So how do we turn the A3, A4, A5 to A2, A3, A4? Yeah, so we wanna replace the A5 by an A2, right? How do we do that? Hmm? Does it make sense what we're doing? We're trying to get A2, A3, A4 on all 3 of these things here, yeah? And the top is A2, A3, A4, yeah? Lucas, do you know what to do? Okay, so we assume, see, if A2 is bigger than A5, yeah? If A2 is bigger than A5, yeah? If A2 is bigger than A5, then we can replace A5 by A2, and this fraction will get smaller, right? That makes sense? So we can assume A2 is greater than A5, then you can replace this by A2, yeah? And then these 3 things will add up to less than 1, right? Yeah? And these two obviously add up to less than 1 because it's A1 plus A5 on A1 plus A5, yeah? And then we'd be done, right? Yeah? So what that means is, so what that gives us a lead. So what lead should we follow, do you know? What lead do we follow now? Almost. What lead are we following? So you're right, it's something to do with A2 and A5. No, so you're basically saying the right thing but the wrong statement. So what do we do now, right? Like we're chasing, right? What are we chasing?
A2 is greater or equal than A5.
No, we don't do that because we're already done, right? That when that's true, we're done. You know what I'm saying? Yeah. So what's the opposite? Yeah. So when it's not true, that's when we're not done, right? So we're looking for now. A2 is less than A5. Does that make sense? So it's not greater. So we're not trying to replace this by A2 anymore. Yeah.
Can't you just replace the other A2?
The other A2.
With the A2 and A3 with the A2 plus A3.
Yeah, exactly. So if the 5 is the bigger one, you want to replace A2 by A5 now, right? So Ryan mentions we can take this one and change it to A5, yeah? You see? Okay, what else can we do?
The A2 in that one.
Huh?
A2 in that one.
No, we don't want the A2 in this one because that'll be 1, 5, 3. We don't want 1, 5, 3. We want 3, 4, 5, see? You understand? 3, 4, 5. There's already a 3, 4, 5. We don't have to touch that, yeah? So what else do we do?
That one has a 4, 5 and a 1.
Yeah, that one has a 4, 5 and a 1, right? So we want to get rid of what do we want to get rid of, Michelle? The 1, and what do we want to replace it by? A 3, right?
Yeah.
Because then it'd be all 3, 4, 5, and the top is 3, 4, 5, yeah? So how do we swap the 1 for a 3? Yeah, so if we have A3 is bigger than or equal to A1, right?
Then we can do it.
Then we're replacing A1 by a bigger number, right? So the overall fraction is going to be smaller because you're dividing by a bigger number, right? Does that make sense? So if A3 is bigger than or equal to A1, then these three things here is less than or equal to 1, right? And then we're done again because those two are less than 1. Yeah? Okay. So then what do we do now? No. No. What do we do now?
I'll imagine it's the exact same thing we did with the A2 and A5.
Yes.
The A3 and A1. So
yes.
is A3 smaller than A1?
Yes, exactly. A3 is smaller than A1, right? Because if this is true, we're done, right?
Yeah.
So we just care about the case when it's not true, yeah? So we want to investigate when A3 is smaller than A1, right? Blue is probably not the best color. Yes. We want A3 is smaller than A1, yeah? That makes sense?
Yes.
Okay. So if A3 is smaller than A1, yeah?
Yeah.
We're not going to try to replace A1 by A3 anymore, right?
Yeah.
What are we going to try and do?
A3 by A1?
Yeah, and where can we do that?
There's an A3 in the A4 section.
There's this one here, right?
Yes.
We can replace that by an A1, yeah?
Yes.
You see? And then where do we go next?
That one, because it has the exact same number.
So there's the same one, right?
Yes. A11.
And so then which one do we go to next?
A11.
A11.
Actually, no, the A1 already A1.
Yeah, so this one we don't have to touch, but we want to use that, right?
Oh yeah, A11.
This one,
Yeah.
the A11.
Yeah.
Okay. Wait, Michelle, you understand? Huh? Yes? So these three things, we want them all to be 145 on the bottom, yeah? So this is 145, this is 145, and this is 152, okay?
So the 2 has to become a 4.
Yeah, so we want to replace the 2, A2 here by A4.
Which means
You understand?
A4 equal or greater to A2.
Uh,
Right.
yeah. So we have A4 greater than or equal to A2, right? Very good. So if A4 is greater than or equal to A2, Michael, do you understand? If A4 is bigger than or equal to A2, right?
Yeah.
Then you're replacing something A2 by a bigger number in the bottom, yeah?
Yeah.
And then this thing will get smaller, yeah?
Yeah.
So then this thing will be smaller than when it's just 145, yeah? And when it's 145, they have the same denominator. The top is also 145. You add them, you get 1, yeah?
Yeah.
You understand that?
Yeah. Why do you
Because they have the same denominator. Look, so you have, the bottom is A4 plus A5 plus A1, right? So they have the same denominator. That means you just add the top, yeah?
Oh.
But the top is just A4 plus A5 plus A1, yeah?
Yeah.
You see?
Which makes it one whole.
You understand?
Which makes it one whole. Wait. Why does A4, A5, and A1 equal to?
No, because it's the same at the top as the bottom.
Yeah.
If you divide something by the same thing, it's going to equal 1.
Yeah.
Yeah? Alright, Michelle's, are we following? Okay. So A4 is greater than A2, that means this is all less than 1, and then this is less than 1, we know that, right?
Yeah.
So then we'd be done, right?
Yes.
So what do we do next?
A2 smaller than A4? A2 is bigger than A4.
Yeah, A2 is bigger than A4. So A2 is bigger than A4, yeah?
I accidentally said A2 is smaller than A4.
Yeah, so if A2 is bigger than A4,
Then that means A5 is bigger than A4.
mm,
We can do the A4 inside
yeah.
the A5 thingy.
Yeah, so this is already a problem, but we can keep going. See, can you see there's already a problem here?
Why?
Because now A2 is bigger than A4, A4 is bigger than A1, A1 is bigger than A3, A3 is bigger than A5, and then A5 is bigger than A2, yeah? That's not allowed, right?
Yeah.
But we can still keep going. We'll even get a direct contradiction. So if A2 is bigger than A4, what do we want
We
to?
can do A4 in the A5 section.
Yeah, so we want to replace A4 by A2, yeah?
To make it 512.
So here we can make this.
A2.
We can make this an A2, right?
Yeah.
And then we get 125, yeah?
Yes.
And we already have a 125 here.
Yeah.
We can try to make this a 125, yeah?
Yeah. So we can replace A3 by an A5 because we already have A3 is bigger or equal to A5.
Yeah, so no, A3 is bigger than or equal to A5, so we
So we can replace the A3 by an A5. Actually, no, we won't do that because A3 is bigger than 5. So that means A3 can't be replaced by A5.
yeah, so we want
A5 bigger than A3.
so we want A5 bigger than A3, right?
Yes.
But
But it already says A3 bigger or equal to A5.
yeah. Yeah, so I guess we can't go on any further, but can you see we reached a contradiction? Like A2 can't be bigger than A4 and be smaller than stuff that A4 is bigger than, right?
Yeah.
So look at this. A2 is bigger than A4, is bigger than A1, is bigger than A3, is bigger than or equal to A5, and is bigger than A2. Yeah.
We could.
Does that make sense? That's a contradiction.
Yeah.
So can you see how we could generalize this to the entire problem? It's not too difficult, right? You just keep going around. Like, the nice thing is, like, we never had to go to a random spot. Like, we always went to the next one along. Yeah? Does that make sense? So in general, I guess in general it'd be like, this would be like k plus 1 or something. You have like 8k plus 1 on 8k plus 8k plus 1
Oh, we don't know what 8K is.
plus 8k plus 2. And this is like 8k.
How will we solve K?
Oh no, we don't need to solve k. K is under our control, yeah?
Oh, so K is anything we want it to be?
Yeah, but we wanted to run through all the 1 to 99, yeah?
Okay. What does that sideways add mean?
It means add them all up.
Oh.
Like how we added 5 things up before. Okay, let me just write 2 more terms.
Oh wait, it tells us what K equals. It says K equals 1.
Yeah, so
K equals 1, then just A1 plus 1.
so here what you can do is, can you see what we do? We assume, so we can assume if we can get them all to be the same as like AK plus 1, say here, right? So this is K, K plus 1, K plus 2, yeah? So we want this to be replaced by 8k plus 2. And we want this to be replaced by k plus k, right? That makes sense?
Yeah.
So we want ak minus 1 to be less than or equal to ak plus 2, right? And we want ak plus 3 to be less than or equal to ak, yeah? Does that make sense? And so basically, we can guarantee one of them to be true, right? We can say the other one is not true for the sake of argument, yeah? And then we can keep increasing k by 1 until we get it all the way around again. Does that make sense?
Yeah.
Does anyone have any questions? It looks more complicated because there's a lot more. You're going to do it 99 times now. Yeah.
99?
Wait, do we actually have to do it 99?
Oh no, you can make up like a general rule probably. So, if we start with, let's see. So we started with the 3 and the 5 last time. So if you're trying to replace k minus 1 by k plus 2, yeah. So we want to probably start with this one. So we want this one, yeah. So keep that one, right? And assume this one's not true, yeah? Okay. Then that exactly allows us to replace this one by minus 1, right? And so we want to replace this one by minus 1, yeah? Wait, what? Wait, sorry, what is, so AK plus 1 is greater than AK plus 2. So we want to replace AK plus 2 by minus 1, right? Something's not right. The 3... minus 1 plus 1 yeah, I feel like we were already done. AK plus 3 is less than AK. I feel like we're moving backwards. Okay, so if we're moving backwards, then it's the one that's off the screen on this side that we need to deal with, right? So that's the AK minus 1, AK and AK minus 2, yeah? So we want the AK minus 2 to be replaced by AK minus AK plus 1, right? So we want the AK minus 2 to be less than your AK plus 1, right? Which means we get AK minus 2 to be greater than AK plus 1. Yeah? Alright, maybe assuming the other one will make us go this way, it'll be more comfortable. Let me just try it. So, what happens if we assume... So if we keep that one instead, right? And we change this one, yeah? Then that means we want to be replacing AK by AK plus 3. So we're going to this one now, yeah? So this will be an AK plus 3. Yeah. Okay, and then we want to do the AK plus 4 and change that to an AK plus 1, right? Yeah. Okay, so now we're talking. So then we got AK plus 4. If it's less than AK plus 1, right? That's true. Then we want AK plus 4 to be greater than AK plus 1. Yeah. That makes sense? Yeah, so that's sort of what's called, have you heard of induction? Induction is kind of where you, like, instead of doing it 99 times, if you're just counting, you just kind of do the general, like what the general step looks like, and then you say you've done it 99 times.
Oh.
Does that make sense? So here it's like, you see, we got from K plus 3K to K plus 4, K plus 1. So everything just increased by 1, right? So the next thing we're going to get is going to be AK plus 5 to AK plus 2, you see? And so that's going to go all the way around, yeah? Does that make sense?
Yes.
So basically you're going to get, everything is greater than the one that's 3 or the next. Does that make sense? Okay, so if you just keep going around in 3s, right? So eventually you're going to get that AK plus 2. You're going to eventually get AK minus 1. So if you keep going around in 3s like that, Right, so do we get AK plus 4 is greater than AK plus 1? Yeah. So if we keep going around like that, we're going to get like A anything is greater than the 3 minus, A 3 minus that thing, right? That thing minus 3. So we're going to get like, so for example, we might get, so how do we do this? So we might get A99, right? Is greater than A96, yeah? It's greater than A93, yeah? That makes sense? And you just keep minusing 3, because 93 is a multiple of 3. You're going to get it's greater than A3, right? That makes sense? But then if you minus 3 from that, it's going to be greater than A99, see? You see that? So can you see this is the same idea for the contradiction as for 5, yeah? It goes all the way around and it's greater than itself.
Uh-huh.
Yeah?
Is that good or bad?
Huh?
Is that good or bad?
That's a contradiction.
Is that
So it means at some point, some of these things have to be true, yeah? That makes sense? It can't be false forever. So that means 3 of them is going to be less than 1, and the rest of them is going to be less than 48, yeah? Does that make sense? Does everyone understand that? Michelle? Michelle?
yeah.
Michael? Lucas?
Hello?
Lucas? Where did Lucas go?
Hello?
Lucas, do you understand?
One here.
Okay, we hope the people watching on the video understand too, yeah? The Kings.
Wait, is the video live?